Hello, ladies and gentlemen. My name is Mr. Bryce. I'm at Susquehanna Valley High School in Conklin, New York, and we're going to be going over some principles dealing with the absolute value for my pre-calculus class. So the first question on the worksheet is, if x is positive, then you don't need to write absolute value of x, you just need to write x. Of course. The absolute value of 3 is just 3, so it doesn't matter. The absolute value of 27 is just 27. So if we know that x is positive, you don't have to write the sticks next to the absolute value bar. So what happens if x is negative then? Well, we also don't need to write the absolute value bars. We just have to write negative of x. That's the opposite of x. So for instance, the absolute value of negative 3. Remember, x equals negative 3. So we just drop the sticks and put a negative sign. X was negative 3. So we just put it in parentheses. What's the negative of negative 3? Negative 1 times negative 3 is 3. It checks. What happens if we have something like the absolute value of negative 302? Still the same thing. We know it's 302. You just write it's the negative or the opposite of negative 302. Just multiply by negative 1. And we get positive 302. You have any questions, raise your hand. If you're in class, if we're not in class or watching at this home, then just ask a question at home. Write these without absolute value. Okay? First of all, we have to examine it. Is the first one. I lost my smiley face. Look at it. Is this negative? Negative 3 minus 2 is negative 5. Yes, it is negative. It doesn't say simplify. What I am looking for is the fact that it's the negative of negative 3 minus 2. Distribute your negative 1 throughout, and we get it's 3 plus 2. So we're looking for 3 plus 2 right there. You have an approximation of that. That's approximately 6.28. Yes, it is greater than 5, so it's just 2 pi minus 5, because a larger number minus a smaller number is going to be positive. So that's a positive answer. 10 minus 11, last time I checked, that's negative. So 10 minus 11 is the same as negative 10 plus 11. You got the idea? We have an approximation. Sorry for the interruption. Let's see if I can pick up where I was. Now, what we're going to do is we're going to approximate the square root of 3. Well, the square root of 4 is 2. It doesn't matter. It's positive. We're adding a positive number onto it. What's inside the absolute value has to be positive. So it's the square root of 3 plus 4. Now here, the square root of 5 is a little bit bigger than 2 because the square root of 4 is 2. So that's bigger than 2. A 2 minus number bigger than 2 is going to be negative. So we have to take negative 1 times the quantity 2 minus the square root of 5. I know, you just say, just change them to their opposites. Okay. That goes there. So this is what your sheet says. Your sheet says write these without the absolute value. Well, they're very boring. If you take a look at this, x is greater than 4. Okay, that means that this is going to be a positive quantity, so it's just x minus 4. X is less than 2, so we have 2 minus a number smaller than it. It's just 2 minus x. Okay, x is greater than pi. That means this is bigger than pi, so this is just x minus pi. It's the same thing. So why don't we do a couple of these questions So here's a set of questions. You can hit pause and do them fast, and then hit play and see if you have the same answers as I do. First of all, x is less than 5. So we're going to have something like 4. 4 minus 5 is a negative 1. So what you do is you put negative x minus 5 in the parentheses, distribute the negative 1 throughout. It's negative x plus 5. Rewrite it without the bars. X is less than negative 3. Okay, so negative 4. 3 plus negative 4 is a negative number. How do we do that? Again, we put the negative sign through there. 3 plus x. Distribute the negative. It's 3 minus x. Okay, yes, you can do that without showing any work. Now, x is greater than 2. Triangle 3. 4 minus 6. What do you mean 6? I mean 2 times 3 is 6. So 4 minus 6 is negative. So again, for those of you that can't do it yet, we have to distribute the negative 1 throughout, and we have negative 4 plus 2x. Okay, if you have any questions on these, make sure you ask me after class. We're going to go on to the next page right now. Hang on. Okay, so this is what number 5 looks like. It says solve for x and give the answer in interval notation. That's with brackets, parentheses, opened or closed. Okay, so we just saw a whole bunch of examples where we had whether we're going to negate it or we're not going to negate it. Okay, and so here we're going to have the positive values where we're just going to leave it alone, drop the absolute value, add 5 to both sides and divide by 2. And then we're going to have the negation values. I decided to show you the work for the negation values. Okay, so you notice that the absolute value of the properties were just turned into parentheses. I put a negative 1 in front. The less than symbol is still there, and the 7 is still there. So you have negative 2x plus 5 is less than 7. Subtract 5 from both sides, and we have negative 2x is less than 2. Divide by negative 2, x is greater than negative 1. Okay, now let's take a look at that. What if x isn't greater than negative 1? Let's grab a test, like negative 2. So what we have is we have the absolute value of 2 times negative 2 minus 5 has to be less than 7. Well, 2 times negative 2 is negative 4. Minus 5 is negative 9. And the absolute value of negative 9 is not less than 7. So it's not true. So we just tested the case a little bit farther to the left of the number line where it was less than. Of course, the question says write an interval notation. So what we have is we have numbers that are bigger than negative 1 and smaller than 6. Is 0 smaller than 6 and bigger than negative 1? Yes. So that's going to be the case that, first of all, they're going to be parentheses. It's going to be negative 1 all the way up to 6. I'm going to erase this in 3, 2, 1. Now let's take a look at the other answers. Okay, so let's take a look at the answers here. The answer to this second problem is the interval from 3 to 9 inclusive. The answer to the second problem, or the third problem on the series, is negative 6 to 6 exclusive on both. Okay, this is fairly straightforward. What I did here was drop it, find a common denominator of 6, multiply both sides by 6, divided by 5. And then the negation of it, we only negated the left-hand side. These are the positive values. What are the negative values? That's the question here. So I negated the left-hand side just like I did before. Distributed the negative 1 throughout. That's the only thing I did there. Then I found a common denominator of 6. Combined them. Multiply both sides by 6. Still the inequality is in the same direction. Divided by negative 5. Inverted the inequality. Let's take a look at the last one. And here's the solution. It's the union of two sets, because all numbers less than negative 5, all numbers bigger than 25. Okay, if we notice, and we draw those, it's going to be something that looks like that. And we have, of course, open circles on either end. Okay, number 6, f of x equals x plus the absolute value of 2x minus 4. Close the quantity minus 4. Show me this in a piecewise version of this absolute value function by breaking it up into 2 separate functions. So let's take a look at this. The first thing that we can do is say, where's the action? There's going to be something going on. There's an inflection point, a turning point. What is going on? Right there. 2x minus 4 changes from positive to negative at 0. When it changes from negative to positive or positive to negative at 0, that's where the absolute value is going to have an inflection point. So all we do is solve this very easily. 2x equals 4, x equals 2. So that's the inflection point. Keeping that in mind, that the inflection point is 2, so when x is less than 2, what number do you want to pick? My hero, 0. 2 times 0 minus 4 is negative. So this is going to be negative. When x is less than 2, it's going to be negative. So the first thing we want to do is we want to write the stuff on outside, and then I'm going to put negative 1 times 2x minus 4, closing the quantity, and then minus 4. You get the drift where we're going? So then x minus 2x plus 4 minus 4. Combine like terms, negative x. So one of the functions, when x is less than 2, we're going to have it equal negative x. Now let's test when it's positive. All we do is we drop the, so when x, this is less than, so I'm going to have to make that greater than or equal to 2 because we can't drop out the 2. And then all we do is drop the absolute value sticks, combine like terms. So f of x equals 3x minus 8 when x is greater than or equal to 2. We have our two functions. And over here on the right-hand side is how we usually write them. If you want to copy that down, you want to hit pause right now, because here it goes. Okay, they're back. So let's take a look. They're proved that the two linear parts are not perpendicular. The other teacher said this was a tough guy. Is it? These are not perpendicular because the slopes are not negative reciprocals. Even though they're negative of each other, 1 is not the reciprocal of 3. Okay, now on to the next question. Show me the piecewise version of this by breaking into two separate functions. Okay, all of the action is happening when this equals 0. We just take it out. You can do it by inspection. Of course, the action is happening at x equals negative 4. So if you plug in a number that is smaller than negative 4, like negative 5, this whole thing is going to be negative. So at x being less than negative 4, we're going to have to negate the absolute value. X minus negative 1 times x plus 4 minus 5. You got it? The only thing that I did was insert a -1 right there. I dropped the absolute value sticks, put them inside parentheses instead, and put a -1 in front. Distribute, combine like terms. Okay. X minus -x minus 4 minus 5. Whoa, what happened there? You see that this subtraction, there was a negative and a negative. That could have just turned into a positive. Could have done it that way. Pretty cool, huh? So what's all that work mean? It means that when x is less than -4, I can just use this statement instead of using this statement. I don't believe you. Let's try plugging in -5. -5 minus -5 plus 4 minus 5. -5 minus the absolute value of -1 minus 5. Combine all the like terms. It's -11. Now we do 2 times -5 minus 1. Just plugged in a -5 there. -10 minus 1 is -11. It checks. Both statements are congruent. Now what I did over here on the right-hand side where the green is, I exchanged the sticks, the absolute value bars, for parentheses because of that subtraction sign right there. So what we have is we have x minus 4 minus 5 when x is greater than or equal to -4. I negated it there when it was less than. Now it has to be greater than or equal to. Combine like terms. Uh-oh, x minus x is nothing. -4 minus -5 is -9. So now let's write down our answer. And there's the answer. So we were just dealing with the absolute value functions and breaking them into piecewise. I hope you've enjoyed the lesson. If you have any questions, make sure you get a hold of me. I'm Mr. Bryce at Susquehanna Valley High School in Concord, New York. Make sure you ask questions today in class. Have a great night.